March the 31st, 2026. Guys, you're looking at images from the last few days coming from LASCO C3, and that's the sun behind what's called the occulter disk. Of course, that's there to block out the glare of the sun so we can see what's going on around it. You got other satellites that look directly at it. But what we are dealing with now is all the sunspots that were giving us trouble last month and in the beginning of March have rotated back around, and we're starting to get one in the southern hemisphere of the sun that has thrown off 2 consecutive flares, and one was an X flare yesterday. Now, what you're seeing is a comet. It's coming right up through there, and that's going to be pretty much the direction that our comet coming in, called COMET maps, I think in about 4 days. It'll be coming in. Now, still, there's differences in the opinion of whether COMET maps will make it around the sun, hit it, we just don't know, or do like iSun did. At that time, during iSun 2013, guys, it was a split decision then. Would it hit the sun? Would it be close enough to tear it apart? And that's what happened. It shredded it into a million pieces, and we saw a beautiful comet come in and then rise above here in a giant fan pattern that ended up being about 20 million miles wide. But again, we're looking at Earth-facing images and what's happening. And by the way, this flare that we're watching is going to be hitting the Earth at about 11 a.m. East Coast time this morning. Anyway, this comet, you see it right there? Boom. It didn't make it. It didn't come out the other side. What happened, though, was the sun sensed it coming. And every comet that I've seen that's a sun diver, the same effects happen. Now, when we get to comet maps, it's a lot larger than this comet you see creeping through right there. See that? It's a lot larger than that, but the sun is reacting to that comet just like it would a positive or a negative charge or an opposite charge. It senses it coming and it reacts. Now, I've seen it almost tear comets apart a million miles from the sun. The explosions were so severe. Smaller comet, but we're dealing with an electric universe. We have plasma tubes that connect the Earth to the sun. I've showed you those before, and it's called the Earth-Sun Connectivity Points. It's a spot on the sun that has a plasma tube that's connected to Earth and totally encompasses our planet, and every 8 minutes it pulses. By the time this video's over, it would have already transferred so much flux, basically, that anything could happen. So the more energy that's at that section of the sun as it's floating through that connectivity point area, say a sunspot or something like that, we've seen those activated. So why wouldn't a comet do the same thing? That was my point. Now, we'll look at it a little closer on LASCO C2. Again, this will be the satellite that we get to see comet maps come in on because it's going to be so close to the sun. Now, we're staying on the same satellite, but this camera gives us a much closer look. You notice your view is much narrower, and you'll see the comet coming in from the same area. But right there on the 30th, guys, that's the one that's coming in this morning. I'm going to show you the update on that. But it's very interesting how these comets react, or how the sun reacts to these comets. And you're going to see the explosion on the 30th, 29th timestamp now. Here comes the big one, boom, that's that X flare. And then the comet's going to come in right there. Notice it starts to dissipate as it gets that close to the sun. The larger ones, it could be a totally different story. We may see another iSun type event as maps comes in. Now, as we look at the Enlil solar wind prediction model, guys, notice I'm just going to push it forward. Timestamp at the top, 29th. As we get to the 30th, you'll see the eruption start right there. See it coming off the sun. Now, this one's moving very fast. Sometimes these things take 2 days to get to our planet. But if we pull this thing up, you're going to see right about there is where we're going to start to see, on the average, timing could be off a little bit on the models, that is where we're going to start to see the plasma density strike our planet. If it's in the green line, it's about the planet. If it's in a red line, it's about Stereo A, this satellite right there. Of course, the sun's in the center, and there's the green dot of our planet. Also, solar wind speeds are going to go from around 400 to peaking into the 700s, according to this model. That could rise. We've seen that happen before. Anyway, at 1600, guys, that's at 11 a.m. on the East Coast. That's 10 a.m. here, which is 45 minutes from now. It's moving pretty fast. I saw the report yesterday, and we're going to see some effects, but it wasn't a long flare. And so you've got maybe 24 hours of feeling this thing as it is around and close to our planet. You can see in the green line here, guys, that starting just before the 1600 hours today, and then it stays elevated for almost a day. See that as it starts to go down and then averages back out. Solar wind speed's going to last a little bit longer behind it, and you can tell that here in this section of it. So we'll have high solar wind going in for, let's see, 1, 2, 3, possibly 4 days of high solar wind, and we can always feel that. It puts pressure on us. It puts pressure on the tectonic plates of our planet. Now, guys, this is the current model for maps in our solar system, and let's get a Earth-facing perspective. Earth is right in the center of the blue dot. Here's the sun right there. And let's get that ecliptic pulled up, and you can see the line right here. This is both the entrance and exit lines of the comet right here. You can see how closely that distance is right there. Will it make it? We don't know. Will it, because of the gravity of the sun, get even closer than that? Some models are saying yes. Either way, it's going to be a spectacular show, but again, it's going to be coming up, looping this way according to this model, and then back down. Let me back it out. Again, very much the way, and it could be part of the same comet group of that sun diver we just saw. See where it maps is at right here? And it almost on the same line, except it didn't make it. It was too small, it was too close. It didn't make it, nothing came out the other side. But this is the maps. If it makes it around intact, that's going to be the exit area here. And if it's not intact, it could be a debris field, very large. And before it's all said and done, it will be a new meteor shower, just like at one point in time, ISON's debris field will become a meteor shower. That's way into the future. But this is what we got. Now, again, this is today, and there's one of my huskies fussing about, probably wanting another treat right now, and that's one of the little girls. And so let's advance this forward. We'll put it, it's at 1 day. There, we're going into the 1st, April, the 2nd, 3rd, 4th, 5th. On the 5th, it's already came up and went back around. So if we move this, so let's change this to hours and back it up a little bit. You can see where it's at in the orbital pull of the sun right there, slingshot effect. And what happens is that they speed up. Once they get into the inner solar system past Mars, or the distance of Mars from the sun, I saw ISON go from 1 million miles a day to 11 million miles a day as it approached the sun. And then because of its mass, it went out into one of the most beautiful displays I've ever seen. And again, so we're looking at here on the 4th of April, 1400 UTC time, that would be about 9 o'clock on the East Coast, would be when the wrapping effect will happen, when the slingshot occurs. So again, tomorrow's the 1st, so we'll be looking at, let's see, Thursday, Friday, Saturday, UTC time. This thing will become, possibly by Friday, it will become visible on LASCO C3, that blue satellite that we just saw. Okay, baby girl, you're going to get a snack. I'm almost through. They are so stubborn. Now let's go back to Thanksgiving 2013 and look at Comet ISON, guys. This thing was amazing. And we had different people projecting the path. Check this out. Coming in here, we watch it. You can see that curve start to create right here, uplifting because of the gravitational tug of the sun. And it's moving at 11 million miles a day. And when it makes that slingshot, that's what happens right there. It fanned into millions of pieces, and then the sun gave it a goodbye slap with those series of solar flares. And that's how much energy was transferred between the two. But if you notice, guys, one more time, it was reacting also to the incoming. See that? It's reacting to ISON approaching, going crazy, really. And then as it wraps around it, explodes out the top side, going back into orbit with a huge meteor shower. The solar eruptions continue in that magnetic pull. And it was amazing. A lot of people had decided before daylight that the thing had hit the sun. We kept watching it, and before daylight, this is what we saw. It did not hit it, and that's a good thing. It could have been a disaster if a comet that size plowed into our sun. So we were very fortunate. Now, MAPS is very large. It's a magnitude 7 now, and that means it's very bright, which it's indicating it's very big. It could be a mile or so wide. We'll see as it gets closer. We'll get better pictures on it. And each day, the data coming in from the JPL in Pasadena, California guys is showing the increase in, or the decrease in the numbers in magnitude, which is, as it decreases, it gets brighter as the numbers do. And that indicates size and everything else. It's going to be a very interesting display here in just a few days. We should be able to pick it up, I'm hoping, at least a day before it goes behind this blue disk that we just saw ISON make that move. And it'd be interesting also to see if there are other objects with it. And again, that path that we saw the sun diver in the beginning of this video is very close to the path of MAPS, and that makes me think there could be company. Anyway, we're watching it, guys. You watch it. It's a heads up. Be safe.